I'm here today to speak with you about IC.IDO, and what you can see on the screen going on behind me is a collaborative virtual workspace, IC.IDO's CoLab. And if you think about doing collaboration in IC.IDO and the way we've showcased these demos in the past, is that one of the risks that we run into and one of the challenges I face is the fact that I'm always showing you these demos of the completed work product, of that final validation setting. And quite often people might think about IC.IDO and they're like, well, if you're only going to add value for that final validation setting, they don't see why they should use IC.IDO for other parts of their workflow. And that's part of what I would like to showcase for you today, something a bit more than, yes, that's super cool what's going on here, right? The whole idea of having a virtual engineering review where I can have a room full of people using, well, head-mounted displays that have no business having a full engineering model made directly from CAD without optimization or gamification being able to run on it, but yet you can see that that's what's happening on screen right now. Now we'll get there, and I promise you we'll get there, but I want to talk to you first about what is the other type of work that people are using IC.IDO to accomplish, and what are the other value that you can extract from your use of it in your enterprise. To help stage this aspect of the demo, I want to think about today's demo in 4 different parts, as if we're crossing various milestones in the vehicle development on our way to start a production. So let's start first with early on in product engineering and product concept and product design. Maybe we have to work on a system by system level to make sure that those individual components and individual subassemblies are well compiled, well integrated with each other. And that's a task that we would normally have to do inside of a digital mock-up. Maybe we're having to use our CAD system for it, or maybe we're going off to our vendors and having them make pre-production, production intent parts or prototypes that we would use to validate, can these things actually fit together and will they get the job done? In contrast to that, what we could consider doing is using IC.IDO as a virtual piloting environment where we could pilot that subassembly of just the EV power system and just make sure that the power system itself is well integrated. So that may be just us taking the drivetrain itself, the battery itself, and then the cables that connect the batteries to the drivetrain, and making sure that those are well engineered and well integrated to serve their function together. So that's what we could take a look at in this video. And so in this video, I'm working with IC.IDO on my desktop, and in this case, maybe I'm just the electrical engineer. I'm worried only about the design of that cable harness, the routing of that cable harness, and making sure that I have the right connectors and the right engineered length and the right path for this to be a sound assembly. So you can see I'm just tracing out that path, and those are where the various hard points were, where this is going to assemble and attach to the underside of the unibody of this future car, and I want to make sure that it's well integrated. Now normally if I want to know if the wire harness does its job, then that would require either somebody has to fabricate that wire harness for me as a one-off or a few-of-a-kind engineering sample, or I could instead take that same CAD design data, and rather than shipping it off to the vendor and asking them and paying them to make me that custom wire harness, I can instead bring that into IC.IDO and give it elastic material properties so that I can now treat it like a flexible body inside of IC.IDO. So now what you can see is that inside of VR, I am there in front of a virtual battery, holding in my hand a virtual wire harness, and I'm connecting it to the battery. And I'm doing so in a very experiential way that feels to me, when I'm in VR, I'm immersed in that scenario. I'm doing that work. Now I'm holding a hand controller. I'm not doing this with my bare hands by magic in VR, but I am still participating and experiencing that product on a component or subsystem level in a way that, well, even if I had the entire car available to me, I would not necessarily be able to isolate it this way and reach the same conclusions that I might. And the conclusions that I have right now is that, well, the cable harness seems like it bolts in right, but maybe that length was such that I risk every time I'm plugging in those ends and making those routes, I'm taking that cable harness and unclipping it from how it's being staged in this tooling before it actually gets bolted onto the underside of the car. And maybe I came to the conclusion that one of those or two of those cables were just too short. Now, inside of IC.IDO, I have full flexibility to take those cable harnesses, and now I could just increase their length. So I'm just dragging that little on-screen manipulator a few millimeters away from its origin, and now you can see in real time those cables are longer. Now they're going to have different physical interactions, and you can see that now that they're longer, there's a bit more slack and a bit more room for this kind of interaction, cable-to-cable collision or cable-to-cable interaction. But then I would be able to put my head-mounted display back on, go back into VR, and reassess. Did making this cable longer or shorter inherently change the engineering decisions that I would have made about that harness at this time, without having to wait the months or the years that it'll take before this thing is physically realized and available to me in the plant? After crossing that milestone, maybe the next step is taking the learnings from that engineering outcome, bringing that back into our PLM system, as Peter and Mark were talking about earlier, maintaining the continuity of that digital thread, and feed that back into our PLM system, and then the engineers are going to design in earnest around that. They're going to do their due diligence. And one of those teams of engineers is probably made up of folks who are professionals at designing jigs and fixtures, these tools that are going to help us stage those different subassemblies, those different components, so that they can be assembled to that final vehicle structure later on in the assembly plant. So maybe now we're at the milestone toward the end of product design, where we're releasing that product so that it can be sent to the vendors to start ordering or commissioning the tooling or ordering the parts themselves, and then kicking off our design of the plant and the plant hardware, the assembly line, the assembly cells. Do an integration check between the tooling, the jig and the fixture itself, as well as the parts components, and then can humans walk around and cable that thing the way that we anticipated? So let's go ahead and take a quick look at what that would look like if in fact I did do that cabling and now just that tooling. So now I've kind of isolated just the battery and just that, I believe that's a power distribution block that goes on top of a plug-in hybrid. And in this case, I'm just routing the cable from where the tooling engineer has told me they're going to stage those intermediate positions of the cables, and then I'm making sure that I can plug that cable into the battery without it jumping off of that fixture or possibly straining or damaging the cable or the tooling itself. I want to make sure that I can attach that cable connector to the top of that power distribution block. Now, one thing that sticks out in my mind right away that I didn't notice before when I was on that part-only integration check, maybe a couple weeks ago, maybe a couple months ago, is that now when I look at it with the context of tooling, Orange Me is standing right in the middle of the car when I was plugging that cable into the battery and plugging that cable into that power distribution block on the top. So I can see that what I thought was a passing process, a feasible process, once I apply more of the context of how human beings are going to be walking around that vehicle as they're doing the assembly in the assembly plant, their accessibility and reachability with the context of the tooling is totally different. At a still later milestone, product engineering hopefully is keeping product design fairly stable, right? They kept it frozen beyond the product design freeze, we hope. The tooling has been maturing, we've been evolving, we've been adding, we've been iterating more and more knowledge about our tooling. So now we have the assembly process, the tooling line and equipment, and we have the intent for the battery and the cables themselves. And now we can take them, and if we were working the way that I showed you in those first two video clips, those were different engineering sessions. Now they were hopefully spawned by the same data coming through that digital thread through our PLM PDM system. But what I'm able to do is I'm able to take the work product of these two individual engineering sessions, IC.IDO sessions, and I can bring them together and add them to each other without having to rewrite the rules about how physics works, how virtual reality works, and all of those things. And in doing so, I'm now streamlining or weaving a more coherent digital thread. I'm taking the tooling process and tooling engineering work, I'm taking the product design, the product engineering work, and I'm merging them together into a single session. So what you're seeing on screen right now is me just making that transition. I've taken two separate IC.IDO session files, one presumably created maybe a month ago by me, the product engineer, and then the other one created more recently by me, the tooling engineer. And when I bring that work product together inside of IC.IDO, I can pop on my head-mounted display, and whatever physics, whatever virtual reality rules I've written earlier on in the process, those are still existing. They're still beneficial. And I can use them now to perform a more detailed, a more complete validation of that human-centric process, that human operation of the tooling and the cabling all together. And I'm able to do that inside of a virtual environment safely without risk of damaging the products, damaging those pre-production models, incurring downtime in my production facilities or my piloting plants, and while minimizing risk of injury or discomfort by my workers. And I'm able to validate that by taking this data and just building on it incrementally. The earlier I start with IC.IDO, the earlier and the more mature I have complete product data in a virtual environment. So there's been this tendency when I show people the collaborative virtual workspace and what we're able to do with Cloud XR, they go, oh, where does that entire scene come from? Well, hopefully you've already been working with it inside of IC.IDO to get you this far, so that now when you move to that next video that we have in our scene, where now we have inside of our collaborative workspace the combined group of that whole rolling chassis, the cables, the wirings, that assembly line and tooling, and then of course the different humans and the teams of humans that might be working on it. Now I can benefit from that and review that in a very immersive collaborative environment. So what you see on screen right now is our team in Rungis, France, and they're able to, in that same space, walk around with each other, walk around that virtual car, and to them, that car is sitting there in the center of the room. This is an entire tacto, an entire station of that assembly line that now contains that entire battery structure, all of the tooling. You can see the cabling on one side of the car and the battery is on the other side of the car. And now we can see that it is going to be a challenge for the people in the green shirt and the blue shirt in this video to be able to reach across and grab that cable connector to plug it into the battery. They're going to have somebody on the other side of the car. And now I'm learning more detailed things about my proposed process, that my production intent is going to require at least one person on one side of the car and another person on the other side of the car to hand that cable and receive that cable from their colleagues so that that can be plugged into the battery correctly. And these are things that I might not have had an opportunity to learn. I might not have really mastered this until I actually had those same human beings that you see in virtuality doing this assembly process, until they were in reality, in meat space, standing adjacent to and with those physical objects in real time. And that's way too much waiting. That's far too long and far along down that engineering process of product development. And it might be too late to change things once I have these physical manifestations of my product or my manufacturing environment. And by validating these stepwise in those incremental steps, I am always emerging that low-hanging fruit. I'm always seeing that low-hanging fruit much earlier, and then I'm able to resolve it when it's cheaper. And now when we're in a more detailed, let's think of this as the full review, or maybe this is the final validation before we start, production tooling, is that we're able to validate this in a very physical, very true to life way that emulates as close as possible, but without physical construction, what we expect to happen when you go into physical prototyping. So a collaborative virtual workspace, it's not the beginning, nor necessarily the end of the process. It is another one of these milestones that we will have to cross in order to continue launching and planning our products on time. Because certainly, at the end of this virtual review, chances are those two people that you see walking around that proposed electric VTOL, they're going to have a list of concerns. They might be concerned, is it too high to reach up and grab that door and close that door manually? Is it too low, the distance between the ceiling and the floor? Will I actually be able to get into that vehicle comfortably and safely? Will I be able to get in and out of it comfortably and safely? And these are questions that are best answered when we let humans interact with these products. But if I always have to wait until the construction of physical products or the optimization and the gamification of those digital models, I might defer those decisions, and I might end up, by not deciding, we are actually painting ourselves into a corner quite often.